Hello and welcome to The Daily Space. I'm your host, Dr. Pamela Gay,
And I am your host, Beth Johnson.
and we are here to put science in your brain.
To start today's episode, we bring you the universe's latest example of a star system we didn't think should have a planet, most definitely having a planet. The European Southern Observatory's Very Large Telescope in Chile has imaged a planet orbiting a binary star system. The two stars have a combined mass greater than 6 times the mass of our Sun, and the planet is a massive 10 times the mass of Jupiter. This large world orbits at a very large distance. It is 100 times further from its stars than Jupiter is from our Sun. In our solar system, this would put the planet out in the middle of the Kuiper Belt. We are able to see this planet reasonably easily because the central stars are giving off so much light that the planet can then reflect back to us. And it's those stars that make it so confusing to find a planet. When this system was young, those two stars were blasting surroundings with amazing stellar winds and radiation, and it had been thought that protoplanets would get disrupted before they had a chance to grow. But it turns out planets gonna form where planets form, and that appears to be absolutely everywhere. With larger and larger telescopes coming online in the next few years, it should become possible to make out features of this widely separated planet and learn more about what it means to be a planet in a system where the stars are so overpowering.
One of the basic rules of the universe is big things have the potential to do highly energetic things. Those big stars had the potential to be the destroyers of worlds. They just happened to let at least that one planet survive. Those stars have nothing on the power of galaxies. 55 million light years away, the galaxy M87 hosts a massive galaxy that is actively eating infalling gas and dust. As this material spirals in, it generates a massive magnetic field. And that magnetic field, well, it acts a bit like a railgun and fires particles out in a 3,300 light year long jet. In new images from the Very Large Array, astronomers have examined the structure of that jet and discovered that it has a delicate double helix structure. These findings are published in the astrophysical journal Letters with lead author Alice Pesesto. According to co-author Jose Marti, helical magnetic fields are expected close to the black hole and are thought to play a highly important role in channeling the material into the narrow jet. But we didn't expect to find such a strong helical field extending so far outward. According to the National Radio Astronomy Observatory's press release on this study, scientists suggested that instabilities in the flow of material within the jet could make the magnetic field more ordered at the distances seen in the new VLA images. The instabilities produce regions of higher pressure, which also compress the magnetic field lines. These instabilities, in turn, are thought to produce the distant double helix structure. This research shows again that we think too small. The universe once again builds things on a grander scale than we expect.
The scale of things in our universe is really something outside our ability as humans to understand. And across all those different scales, the physics works the same. Just as infalling material around a black hole can power massive jets, infalling material around a forming star can also form jets. Smaller, less exciting jets, but jets all the same. In a new image from the Gemini South telescope, astronomers have captured the asymmetric jets of a forming star. A dark band can be seen blocking light from where the star is believed to be. The band is thought to be the disk where planets could form in the future. According to the Noir Lab press release, this system looks like a one winged butterfly. This glowing system is part of a larger star forming region and is surrounded by gas that is reflecting light, casting an eerie glow on the entire scene. After the break, we're going to come back to Earth and take a look at the astronauts who occasionally get the amazing opportunity to leave our planet. Stay tuned.
On December 8th at 0738 UTC, a Russian Soyuz 2.1A launched the Soyuz MS-20 spacecraft into orbit from Site 316 at the Baikonur Cosmodrome in Kazakhstan. On board were cosmonaut Alexander Mazurkin and two paying passengers, Japanese billionaire Yuzaki Mizawa and his assistant Yozo Hirano. Let's watch the launch.
Прошел контакт подъема. Двигатели центрального и боковых блоков ракеты-носители вышли на режим главных по тяги. Параметры системы управления ракеты-носителем в норме.
After a 9-minute flight into orbit, the Soyuz spacecraft separated from the third stage of its rocket and deployed its solar panels and antennas to begin its quick 4-orbit rendezvous with the International Space Station. The Soyuz typically does a 2-orbit rendezvous, but that requires the International Space Station to do some orbital maneuvers, which likely would have required an undesirable decrease in the ISS altitude. The Soyuz docked to the Poisk docking module at 1338 UTC, and after the usual leak checks, the crew was welcomed aboard the International Space Station. Yuzaku and Hirano's flight is the third commercial flight to the International Space Station in the past decade or so, and the second this year, and they will be the second and third Japanese citizens to go to space. A new Soyuz is being used for the short 12-day mission to allow Yuzaka to gain some spaceflight experience prior to his flight around the moon on a SpaceX Starship, which is currently scheduled for 2023, but may actually take place later than that. Like the previous tourist trips to the International Space Station, this one was organized by Space Adventures. In addition to the people, the Soyuz delivered 162 kilograms of supplies to the ISS. One interesting historical note about this flight is that the first Japanese citizen ever to go into space, journalist Torahiro Akiyama, made a trip to Mir in December 1990 on Soyuz TM-11. He stayed there for 8 days before returning to Earth and made the first news reports from space.
Speaking of astronauts, this past Monday, December 6th, NASA announced the selection of 10 new astronaut candidates out of over 12,000 applicants. According to NASA, they received applications from all 50 U.S. states, the District of Columbia, and a few U.S. territories, including Puerto Rico, Guam, the Virgin Islands, and the Northern Mariana Islands. One major change in the selection process for this year was the requirement for all applicants to have at least a master's degree in a STEM field. Another change was because the selection process took place during our ongoing pandemic. NASA used an online assessment tool for the first time. The 10 candidates will begin 2 years of astronaut training at the Johnson Space Center in Houston, Texas next month. These astronauts will be among those chosen to take part in the Artemis program's return to the moon, whenever that happens. They could also be assigned to fly on one of the commercial crew spacecraft on an expedition to the ISS. There are 6 men and 4 women, and most of them have the usual military or test pilot background common of astronauts, going back to the first group selected in 1959. One astronaut candidate, Anil Menon, previously worked at NASA as a flight surgeon on the International Space Station program and was then hired to perform the same role at SpaceX, ensuring their human spaceflight program started off on the right foot. He was also a fighter pilot in the United States Air Force before becoming a flight surgeon. Nicole Ayers led the first all-woman combat format of F-22 fighters. Christina Birch has a PhD in bioengineering and medaled 3 times in the World Cup as part of the U.S. national track cycling team. Dennis Burnham also worked at NASA before being selected as an astronaut, interning at NASA's Ames Research Center. Andre Douglas also has a PhD in systems engineering. Before being selected as a NASA astronaut, he worked at the Johns Hopkins University Applied Physics Laboratory on, among other things, NASA's DART mission. Christopher Williams is a board-certified medical physicist with a PhD in physics. Marco Berrios, Luke Delaney, Jack Hathaway, and Jessica Whitner all flew for various military services. Congratulations to this latest class of NASA astronauts. We wish you well in your training and future missions. After the break, we'll look at how gravitational waves could answer a long-standing question about matter versus antimatter. Stay tuned.
There are times as an astronomer that I look at a research paper, know it is a potentially important paper, and my brain just says, no. That is the case with the next story we're going to cover, and I'm not going to lie. Many cups of coffee went into trying to make sense of this science. Normally, we wouldn't inflict a journal article on you, but just this once, I feel compelled to share the introductory sentences of a physics review letters paper that really wanted to put me to sleep. The asymmetry between matter and antimatter is a cornerstone puzzle of modern particle cosmology, as the standard model fails to provide an explanation. An elegant paradigm for explaining the asymmetry is the Affleck-Dine mechanism. Supersymmetric theories generically have flat directions which have non-zero baryon or lepton numbers. During inflation, a scalar condensate generically develops in these directions, whose non-zero vacuum expectation value, VEV, spontaneously breaks the C and CP. At the end of inflation, a baryon and or lepton asymmetry is generated as the VEV coherently evolves and the condensate fragments. These resulting clumps may be long-lived non-topological solitons, cue balls, carrying either lepton or baryon number. It goes on like that. It goes on. Hidden in that scientific language is a remarkable piece of information, though. Researchers may have figured out why our universe is dominated by matter. This work is led by Graham White. Here's the background you need. When our universe first formed, everything was energy. As the universe expanded and cooled, that energy was able to condense out as particles. Theorists don't generally understand why those particles weren't half matter and half antimatter. Observers and computational modelers, however, find that to explain the universe we have today, there must have been, for every 10 million antimatter particles, 10 million and 1 matter particles. Why? That has been a point of confusion. In this new research, the idea is put forward that during the brief epoch of inflation, during the first minute of the universe, a field was responsible for driving the universe ever larger. This field, like other fields, has associated particles and energies. And as the period of inflation came to an end, those particles decayed in a way that left an excess of matter and bundles of charged cue balls. There is math to back the idea up, and it is math that requires a whole suite of new supersymmetric particles that we've gone looking for and never found, even though they're theorized to exist side by side with our known suite of particles. Again, we've totally failed to find supersymmetric particles, so the theory has a lot working against it. While we can't yet find supersymmetric particles, if they do exist, this paper lays out another possible way it can be proven. The team believes those cue balls are temporary, and when they decay, they would have enhanced the primordial gravitational waves that shaped our early universe. While we can't peer into the pre-cosmic microwave background universe because that microwave background is opaque, we can detect gravitational waves from that era. We don't yet have the equipment to detect primordial gravitational waves, but someday. And it is that someday that makes this paper important. It offers a theory that is testable eventually. It also offers a really nice sleep aid. Not all research is picturesque or can be written in exciting language. Still, even the science that wants to put me to sleep, it can be important to understand our universe. After the break, we'll be back to discuss a meteor shower, one that hearkened me into the universe and makes the myth that meteor showers are bad omens a bit disturbing on a personal level. Stay tuned.
This week in What's Up is yet another meteor shower, the Geminids. This meteor shower is known for being reliable compared to some of the others. However, the time the meteors will be visible this year is limited by the moon's brightness. The source of the Geminids, the radiant, that point in the sky, is easy to find. In the southwest is the brightest star in the sky, Sirius. Follow it well up to the pair of stars that are Castor and Pollux, two of the major stars in the constellation Gemini. The radiant for the Geminids is slightly west of the star Castor, the western star of the pair, as viewed during the morning of December 14th during the peak of the shower. Yes, Pamela's birthday is 2 days before the peak, hence her whole thing about being hearkened into the universe. At 2 a.m. on the 14th, no matter where you are on the planet, it's the peak of the shower because that's when the radiant is highest in the sky. But it's visible starting the night of the 13th. Unfortunately, so is the moon, and it won't set until 3 or 4 a.m. However, the Geminids are usually bright enough that you may see some of them even while the moon is up. At a dark sky site, you can see as many as 50 meteors an hour, and in better years without a nearly full moon, you could see up to 150 meteors an hour. The comet that provides the material for the Geminids is 3200 Phaethon, a rock comet, otherwise known as an asteroid in a really eccentric orbit. In this case, 3200 Phaethon's orbit goes from between the orbits of Mars and Jupiter all the way to 7 times closer to the Sun than Mercury's orbit at 0.14 astronomical units. This is the closest any named asteroid gets to the Sun. It was the first asteroid to be discovered by spacecraft data after 2 scientists found it using images from the infrared astronomical satellite. It was formerly named 3200 Phaethon in 1985. It is a potentially hazardous asteroid because it does cross Earth's orbit, but given that it has been continuously observed for 36 years, its orbit is very well known. The closest it will get in the next 178 years is just inside the moon's orbit in December 2193. Now, our usual advice on how to see a meteor shower. With the unaided eye, the widest field of view you can get. Be sure to let your eyes get well adjusted to the dark. Don't use a planetarium app on your phone. Even if it has a red light function, the brightness will impact your dark adaptation. You can download a map from a link at our website and print it out to bring with you in the field. Use a proper red light flashlight to see the map when you're out. You can get one from Amazon using our affiliate link, so we can benefit as well. A reclining chair or hammock may also be helpful for remaining comfortable for hours of looking for meteors, and if it's cold, bring a blanket. If you want to try to take pictures of this meteor shower, the best way to do this is to use an interchangeable lens camera with a wide angle lens, at least 20 millimeters, wider if possible. Eric likes the new Canon RF 16mm f2.8 lens, which he rented on his own a few months ago to try out. You can also see a full review of that lens that Eric presented weeks ago at a link in our show notes for this episode. Note, we're not sponsored by Canon, but we could be. Mount your camera on a tripod and take very long exposures using bulb mode and a remote shutter release cable, but not an app on your phone because you want to preserve your night vision. And you might just capture a few meteors. So remember, any night with a clear sky is always a good night to look up, but some nights might be better than others. Good luck hunting for meteors. This has been The Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon community at patreon.com/CosmoQuestX.